Okay, student, last time we have seen about the inductance. We have seen three different formulas for the inductance. First formula, phi is L is equal to phi upon I. Second formula, L is equal to E d phi, this E divided by di by dt. And the third formula, L is equal to nothing but 2W. This we have seen. Then also we have seen that inductance of a solenoid, inductance per unit length of an solenoid is equal to nothing but mu 0 n square into A, where A is the area of solenoid and this n is nothing but number of turns per unit length. So this part already we have finished. Now today we are going to consider the next concept, that is nothing but the energy stored in the magnetic field. Now, under this energy stored in the magnetic field, what is the concept? Whenever there is change in magnetic flux, due to that change in magnetic flux, there is a production of EMF, and during that case, there will be a production of current. Current means what? Induced current means what? The charges will start moving inside the conductor, and that free charges which will start moving through a conductor, to force to move that charges, we have to do a certain work, and that work done is nothing but stored in the form of energy. So now your work done to store the work done to be stored in the form of energy. For that purpose, we can use the formula of work. That formula of work is nothing but as a dW is equal to minus E into dQ. Now the question might be comes in your mind from where this formula comes. Now this formula we can write from electrostatic. In electrostatic we have seen that electric potential V is nothing but work done per unit charge, right? So work done dW is equal to nothing but V into Q0. Fine? V is the electric potential, Q0 is a charge. Now here in magnetostatic, electromagnetic induction, what is the thing? EMF is generated. So instead of V, V will be replaced by E. And charges are moving. Which charges? Electrons are moving. So single electron carries a charge which is nothing but dq. Therefore this work done is written in this form. So now I can write down dW is equal to minus, now value of E. This value of E we can write from your EMF generated in the coil, which is nothing but minus L di by dt. So this EMF generated I can write down minus L di by dt into dq as it is. So now minus sign will become plus. So I get dW is equal to L di into, I can write down dq by dt. Just I will rearrange this term dt. dq by dt, rate of change of charge with respect to time, which is nothing but electric current. So what I say, it can be written as Li into di. This is nothing but the small work done. And now this small work done can be calculated with the help of total work done. So what I say here, the total work done W, which can be stored in the form of magnetic energy, which will be indicated by letter capital UV, which is nothing but now integration of dW. So now I can write down W, which is equal to UV, which is equal to integration of dW is Li di, and integration limits are from 0 to I, total current, that is from 0 current to maximum current. So now work done, which is stored in the form of magnetic energy, which is equal to L integration of I di, limits are from 0 to I. I di integration will be nothing but I square by 2. So your magnetic energy is equal to nothing but L I square by 2. This is nothing but your magnetic energy, or I can write down half L I square. This is nothing but the magnetic energy. Clear? Now from this magnetic energy, now we are going to switch over to the magnetic energy density. Right? Now if you are remembering, in electrostatic, we have seen the formula, that is energy stored in the capacitor. If you are remembering, that energy stored in the capacitor E is equal to nothing but half CV square. And magnetic energy is nothing but half Li square. So see this equivalence. In magnetic field, EMF is generated due to current. In electrostatic, energy is generated due to voltage. In capacitor, C is the constant, that is capacitance. And in inductance, L is nothing but the self-inductance. So this is the equivalence. Fine? Now I can consider energy density in a solenoid. Again here solenoid comes. So I will say that energy density in solenoid. Now the first thing is meaning of energy density. Energy density is denoted by letter small ub, which is nothing but magnetic energy per unit volume. Already we have, this is the magnetic energy. So this magnetic energy per unit volume is to be called as energy density. Now volume, which volume we can take? I want to find out energy density in a solenoid. Means I have to consider the volume of solenoid. Now solenoid, what is solenoid? So let's consider this is the solenoid. This is a core. Over the core the coil is rounded. So here is the number of turns of that solenoid. So I can say L is the length of the solenoid, capital N is the number of turns, right? Current flowing through the solenoid is I. And volume of the solenoid, I can consider, this is nothing but the area of cross section. So volume of the solenoid, I can say as a into L, where L is nothing but the length of the solenoid. So now, inside the solenoid, along the center, your magnetic induction is always uniform. And as we go away from the center, the direction of magnetic induction will get diverted. It will become along a curved line. So this curved line indicates that magnetic induction is away from the center of solenoid. And along the axis of solenoid, your magnetic induction is uniform. Okay, now come to this point here. Now what I want? Energy density. Energy density is nothing but magnetic energy per unit volume. Already in this lecture we have seen magnetic energy. What is magnetic energy? This. So now I can put in the formula I am going to put a magnetic energy. What is magnetic energy? Half L I square. This is the magnetic energy divided by A L. Is it right? Now same equation, now I can rearrange and I will write down, that is your magnetic density can be written as half L upon small l into I square upon A. Now here what is the meaning of capital L? Capital L is nothing but the self-inductance. And small l is nothing but the length of the solenoid. And in the previous lecture, we have seen the length of the solenoid, self-inductance per unit length of the solenoid. This formula you have seen as a mu0 n square into A. Where this n is what? N is nothing but number of turns per unit length of the solenoid. Now this value of L by L I can substitute in your energy density formula. So UB can be written as half, instead of inductance per unit length I can put this value mu0 n square A multiplied by this I square upon A. So this AA factor will get cancelled. So now what I am getting here, energy density can be written as half mu0 n square I square. Clear? Now this is the first formula for energy density. Now this formula I can modify by considering this energy density can be written as, now I can multiply and divide by mu 0. Now why? That is the question. Mu 0 n square I square. Again I will multiply by mu 0 and divide by mu 0. Why? See here. Your energy density. Here what I write? Half mu 0 n I bracket square upon mu 0. And this is nothing but your magnetic induction inside the solenoid, which formula you have seen. So now I can write down. So inside the solenoid, in solenoid your magnetic induction is nothing but mu 0 n I. So what I say? Energy density small ub is equal to half b square upon epsilon naught. So this is nothing but the energy density. Clear? And same type of formula you have seen in electrostatic. In electrostatic you have seen electrostatic density is equal to nothing but half epsilon naught E square. This formula you have seen in electrostatic. So this is the equivalence between electrostatic and magnetic field. Fine. So in today's lecture we have seen two concepts. One is nothing but energy stored in a magnetic field. So energy stored in the magnetic field will be denoted by capital UP is equal to half Li square, where L is the self-inductance, I is the current. This is the first thing. And second thing we have seen, which is nothing but the energy density. Energy density, this is your first formula. Energy density is equal to half mu 0 n square I square. And modified formula is energy density is equal to half b square upon epsilon naught. Clear? Any doubt? Okay. Now in the same lecture, I can give one more formula. It is very simple. You are knowing resistor. When number of resistances are connected in series, which are seen in 11, R1, R2 and R3, they are connected in series. So their series combination we can write RS is equal to R1 plus R2 plus R3. Right? Same manner, I can consider 3 coils. First coil has a self-inductance L1, second is L2, third is L3. They are connected. Here coils are in series. If the coils are in series, so I can write down total inductance in series combination is equivalent to resistor, that is L1 plus L2 plus L3. Clear? So this is equivalence between series in resistance and coils in series. Same thing I can write for parallel combination now. Now already we are knowing that in 11th standard you have seen when 3 resistances are connected in a parallel combination as R1, R2 and R3. So their equivalent parallel I am writing 1 upon R3 is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now instead of resistance I can connect 3 coils like this manner. First coil having inductance L1, second inductance L2, third L3. So 3 coils are connected in parallel. So their equivalent parallel 1 upon LP can be written as same as that of resistor, that is 1 upon L1 plus 1 upon L2 plus 1 upon L3. So this formula you have to remember for numerical problem. Clear? Any doubt? So here our concept of self-inductance will get finished. Fine? Ciao.